Hello everybody, this is part 2 of automation, and we're gonna keep doing these tutorials. Eventually we will get to all of everything. I want to do everything, but tutorials first, makes things easier. Okay, so we'll go from here. Unleaded, 5,500 RPM, emissions less than 300, no special manufacturing requirements. So there's a few pistons we can't use. I think special manufacturing includes like CNC and forging. Performance index 165, loudness less than 35, total cost less than 2,900, and reliability higher than 335. So we're starting to get to the point where we actually have to look at our costs, or else we won't be able to do this. So we don't need high RPM, and we need low emissions. So we'll go with the overhead cam. Oh, let's listen to this.
The head type allows you to choose the mechanism with which the valves are actuated. Better heads are capable of higher RPM and have less friction. This allows them to be slightly more economical. Generally, better heads allow for more valves. Having a larger valve count is more advantageous.
This is what the game used to look like. This is what everything used to look like.
The intake and exhaust gases to enter and exit the engine. This makes the engine a more efficient air pump, allowing you to produce more power. The valves are opened and closed by using cams. Cams are covered within the cam profile tutorial.
Okay, so there's that. And you can actually zoom in and look at this stuff. It's really cool. I want very low emissions. Let's change our gas to regular unleaded. RPM limit of 5.5. Engine's knocking. We'll bump down this compression. Now we have to emissions less than 300. We don't need a lot of torque. RPM. So there's that. Oh, it doesn't say about the quality thing yet. Cam profile is economy. Need loudness and emissions. Emissions high. So there's that economy. Okay, let's listen to this.
Manifolds or headers direct the exhaust gases from each of the exhaust ports through the mufflers and tailpipe. The quality of the exhaust manifold can make a dramatic difference in the amount of power the engine can produce. Smoothly curved and long manifolds can make more power at the expense of room within the engine bay, more noise, higher emissions, and greater cost to manufacture.
So we'll go with that. Emissions. We don't want the very low.
Catalytic converters are used to convert harmful emissions
So
into
I
less
think
harmful
we're
emissions.
not at our
CATs can restrict power somewhat
mount.
by limiting airflow, and can only be run on certain engines. Cats generally do not like neither big sporty aggressive cams, leaded fuel, nor rich mixtures. A three-way cat can reduce nitrogen oxides emissions, known as NOx. This can allow you to run higher compression.
Okay. Let's try for a little bit better. We're only at silver. Listen to the
Mufflers
mufflers
make
too.
your engine quieter at the cost of some power. The various muffler types affect airflow and loudness differently and have different efficiencies, but no mufflers will make your engine very loud.
Okay. It's there. Small diameter, less noise.
A too small of an exhaust diameter will limit engine power, as the engine has to work much harder forcing the exhaust gases out of a small area. Whereas too large an exhaust reduces the exhaust velocity at low engine speeds, and diminishes the exhaust's ability to scavenge exhaust gases from the cylinder. Larger exhausts are generally louder than smaller exhausts.
There we go. That is our gold rank. So we go on to the next. I'm gonna try and get gold on most of these. Okay, so no DCOE carburetors, no race intake. Higher than 45. Reliable loudness. Okay. So that, you can't set any of that. Where's the carburetors? We'll do that one first. Oh, use DOC. Okay. Reliability. Can we change lock and head?
The
Okay,
head
let's listen to
material is
this.
similar to block material and allows you to choose between cast iron and alloy. Be warned that mixing different head and block materials can cause significant reductions in durability and lifetime of your engine, especially.
Oh, that's all it took. Oh, I don't want to do that. Make it better. We want more performance, so we'll keep going. Oh, there's the performance to say. Oh, it does do a little. More airflow. Look at that. Just had to up that a little bit. And that is it. That went pretty well. So let's do the stupid small one. Okay, unleaded, size less than that. There, it was set for us. Okay,
The
let's listen
engine
to engine.
configuration describes the number and arrangement of cylinders. Every configuration has its own advantages and disadvantages. The inline 4 configuration is small and compact, but does not have the natural inherent smoothness of an inline 6 or V12. The block material selection allows you to choose between cast iron or alloy blocks. Cast iron is very cheap, durable, but heavy, whereas aluminium alloy is weaker, more expensive, but much lighter.
Okay. Oh god, we can. Ooh. So do that. Aluminum. Size less than... Okay.
Bore and stroke
Let's listen to
determine
this
the
too.
cylinder size. Bore is the cylinder diameter, and stroke is the length that the piston travels inside the cylinder with each stroke. Together, these two quantities help define the capacity of an engine. Longer stroke engines have a slight disadvantage over larger bore engines, due to extra stress generated as the piston travels a larger distance each stroke, effectively reducing an engine's maximum RPM. Larger bore sizes increases the physical engine size, whilst allowing for a limited range of stroke lengths.
The best is probably going to be an inline. Inline 6, shorter stroke. And make this perfect sized. I think it might be 50. Let's go next, I guess. Might as well. Okay, so...
The center of a turbocharger contains a set of very precise bearings for the shaft to run in. Two main types of bearings are commonly used. The simplest type being a journal bearing, which is just an oiled metal sleeve for the shaft to run within. Journal bearings are relatively cheap and simple to manufacture, but are not ideal for the turbocharger's performance as its internal friction makes the turbo somewhat harder to spin. A ball bearing turbocharger uses a casing filled with metal balls to provide a much lower friction mounting for the shaft. Ball bearing turbos spin up more easily and provide a more responsive engine with better low RPM performance. The only disadvantage to ball bearing turbochargers is the extra cost of the more complicated bearings.
Honestly, did not know there was a difference. So we'll do naturally aspirated. What did I forget? Oh, carburetor. Premium unleaded. Requires cooling? Tubular, none. Oh, there we go. that's pretty good for first little one. So first of all, let's go to the beginning. No special manufacturing requirements. Okay, good. So we have to use cast iron. There's that. Now we meet our... We need to get the performance up. More performance. Oop. There we go, there's more performance. Okay, let's see what this is.
In this video, we will cover valve timings, variable valve timing, VVT, and variable valve lift, VVL. Variable valves are a collection of technologies to help optimize the valve train action throughout all engine operating conditions. Variable valve lift, or VVL, is a system that allows for using two different cam profiles, one for low RPM and one for high RPM. This can create an engine with great high RPM performance without making the engine run poorly at low engine speeds. Hence, you need to set two different cam profiles. Variable valve timing, or VVT, allows the valve timing to change throughout the entire RPM range. With the VVT option selected, the timings are optimized automatically, improving power, emissions, and economy. These two technologies can also be combined with excellent results.
Okay, so... We'll go with that. We'll stick with naturally aspirated for now. RPM limit. Leave it there. Our performance index is 26. Oh, our performance index is 32. $31. 1.2. $33.6. I think the engine was actually getting too much air. $34. I just need to get the reliability. Could go with a turbocharger, but let's lower our compression a lot. Actually, before we do that, I'm going to see how that affects it. A little bit lower compression, I think. Wait, I passed it, I think. Pretty sure I did. Where's compression? Compression. $34.2. Oh, I got it. I'm gonna keep making it better. See how much bigger, because I know the stroke will help with this quite a bit. I honestly don't know how much bigger we can make this. So there's that. Bump that up quite a bit. Oh no. Oh, that actually worked really well. Keep making it better. Now we can deal with the exhaust a little bit, because that'll help. I need some more airflow. Not much more I can think of. We'll play with the fuel mixture a little. Oh wow, actually our engine can go a lot higher RPM than I thought. Let's reach its bottom limit. So I don't want to mess with the turbocharger. I think that's the best I'm going to be able to get it. Can I change? Nope, can't change piston size. What's left? I guess as is close. Let's turn to the B flat plane. Nope, the other one's more better. More better. Okay, so that is going to be the end of this recording. This one's actually a lot longer than I planned it to be. It's almost a half hour. Sorry about that. But we got this one done. We got it this silver. Next, I will be doing this one. And sooner or later, we are going to get to the point where one episode is one engine. So we'll see y'all later.